Hey everyone, I'm Will, Ecosystem Growth Manager here at Oasis Protocol. Today we're joined by Javier from Goldsky to go over, how you can deploy subgraphs for either your hackathon project or anything that you're building on the Oasis Sapphire network. Just to promote the hackathon, it's a privacy for Web3 hackathon that can use any of the various products that Oasis offers. So the Oasis Sapphire network, the Oasis privacy layer, or our ROFL, which stands for Run Off-Chain Logic. And I'll be getting into that in a bit. But first, I just want to give an introduction to Javier and let him introduce himself as well.
Okay, cool. Yeah, thank you so much, Will. Good to see you all. I'll be talking about today, indexing and streaming data from Oasis into using Goldsky. Will, whenever you let me go, I'll start the presentation.
Okay, yeah, and I can't wait to get to that part of the presentation. Yeah. I know some of the biggest dApps on Oasis right now are using subgraphs, especially some that are using Goldsky, including Illuminex and I think Nebi as well. Nebi's launching in just a couple weeks. So I know dApps are already leveraging the subgraphs that Goldsky has to offer, and I'm excited to see what people do in this hackathon and in the future. But first, I'd like to just give a brief overview of the Oasis network, or the Oasis Confidential EVM. Let me just share my screen. Can you see, Javier?
Let me see if I can, because I'm also moving my stuff around over here to present. Let's see. Cool, I can see, yeah.
Okay, so I'll do my part very quickly, but the first product that we have is Oasis Sapphire, the first and only, confidential EVM in Web3, only currently. So basically what that means is that we are an EVM layer 1 network that supports encrypted smart contract state. And I'll be describing what that is better throughout the presentation. But starting off, I would like to start with the Oasis architecture. We have an architecture that's very similar, to like a Polkadot or an ETH 2.0, and the fact that it's modular. So we separate execution and consensus, with the major difference being that our consensus layer actually can only handle validation of proofs that come from the execution layer, as well as, the staking smart contract and governance. And that's about it. That allows, because it's so sort of modular, so separated in terms of functionality, it allows us to hit, pretty high scalability while also having instant finality on these networks. So what that means is we have, like I said, the consensus layer as the underlying layer for all of the execution layers. And the execution layers are known as parallel runtimes or paratimes, but they can be thought of very similarly to rollups. The only difference is they're not ZK or optimistic, but in sort of practice, that's exactly what they're doing. Is they're acting as a rollup, which is submitting a bare metal proof to the consensus layer, which is then verified and then finalized instantly as we use Tendermint BFT, or a modified version of Tendermint BFT. So the network today that we're going to be talking about, or the paradigm today that we're going to be talking about, is Sapphire Confidential EVM. So, it's basically an EVM network where all validators on the network run trusted execution environments. Trusted execution environments operate sort of like a black box. So everything gets encrypted on the input side into the black box. Then it gets decrypted inside the black box. Then it runs like a normal EVM inside, and then the output side is re-encrypted based off of what the parameters of the smart contract are, as well as what the user preferences are. What that means is, one, you can build smart contracts that have encrypted state or encrypted storage, which is not possible on other networks. But also what it means is that you can build things that are very flexible in how they add confidentiality and privacy. So you can build things that are entirely transparent, entirely confidential, or anywhere on the spectrum in between. And I say that because I say that the spectrum in between is more interesting, because if we look at Web 2, right, almost everything leverages some aspects of confidentiality and some aspects of transparency. Nothing is ever 100% transparent, and nothing is ever 100% confidential. But this is sort of the way that Web3 has had to operate up until now. And so that's why I'm really excited about this ability to add flexible confidentiality to smart contracts. So if you want to like an example of like where a use case, right, where they're using both transparency and confidentiality, the one I go to is like Uber, right? And they do it in multiple places, but I have to be transparent in my GPS location where I share it to the driver, and I probably have to share it to the Uber server as well. But I don't want anyone in the world to be able to know my GPS location. That would be kind of dangerous. And that happens again on the payment side of Uber, and that happens again on the messaging side of Uber. If you look at Facebook, for example, or any sort of social media, you have the ability to create content, which is transparent to people who are on your friends list, but also you have the ability to hide that content from people that you block, right? And so if we want Web3 to be as sophisticated with similar user experiences to what Web 2 offers, these are the type of tools that we have to have. And so that's what the Oasis Sapphire network is essentially doing. And that's how I'd like to think about it, is helping us to build more sophisticated smart contracts with greater flexibility, which at least have the capability of offering better user experiences. So this is some information on how confidential transactions work. For the purposes of this demo, I won't be going into it just because I think, if you guys have questions on it, you can always come to the Oasis Discord, and we can go over like exactly how encryption, decryption, and all that works on the node side. But I don't think that's necessarily relevant for today. This is a slide where it's basically going over, again, what I just talked about, where 99% of the world operates in some middle ground between transparent and private. So what are some use cases? DeFi. Introduce confidential compute to improve existing DeFi applications. For example, dark pools are something that don't exist in Web3 yet, really. Whereas in like the Web 2 or the traditional finance world, like dark pools are leveraged for billions of dollars every day. I don't know if it counts as DeFi, but sealed bid auctions, right? The ability to have an auction where you don't know what the other people are bidding in the auction can drastically reduce, let's say, the gas inefficiency that comes with like these sold out whitelist auctions, as well as create better systems for the person who's auctioning the item. They get better price discovery, and also the buyer gets better price discovery as well if you implement something like a second bid sealed price auction. Other places are AI agents, verified credentials. So verified credentials, one that we have a demo for is a confidential soulbound token where the owner can actually grant and revoke access to their private data. So imagine like a KYC type system where, let's say you're running a launch pad and you want to make sure that you're compliant. So you want to make sure that all people are above the age of 18, and you want to make sure that they're not part of some 7 blacklisted countries, right? Basically, you can query their verified credential. They can grant you permission to access that verified credential. Some compute can be done on their data, and then a Boolean expression can be sent back to you, where it's like basically a 0 or 1. Yes, they qualify for this launchpad pool, or no, they don't qualify. So you're not actually exposing where they live. You're not actually exposing what their age is. You're just saying they've met this criteria. Gaming is one that I often talk about, but any compelling game that I can think of involves some idea of confidentiality. So fog of war in real-time strategy games, riddles and puzzles in role-playing games, or even just like hiding your opponent's cards and the sort of the deck order for card games. And then we'll probably get into trustless oracles for the raffle section. So soon after we launched Sapphire, we started coming up with ideas of use cases and things like that. And we realized that, really what we wanted to be doing is we want to be pushing Web3 forward, not just the Sapphire network, but the entire Web3. And so we came up with this idea of Opal, the Oasis privacy layer, where you can basically leverage Sapphire as a side chain, where you offload your confidential computation needs to the Oasis privacy layer, and then can get some result. And the easiest way that I normally explain this is like if you imagine just like a very simple role-playing game on Polygon. Maybe the game creators on Polygon don't want to move their entire DApp over to Sapphire, But what they do want is they want to have a puzzle or a riddle that's on-chain in nature. And if you get the answer correct, you get some, NFT item reward. Right now, they would have to take that off-chain. And if you take it off-chain, then, we've sort of lost what makes people interested in Web3 in the first place, which is the trustlessness, the decentralization, and that sort of thing. So instead of you taking it off-chain, what you can do is you can build up your riddle smart contract on Sapphire and then connect them through messaging bridges or some other cross-chain protocols, where basically you're playing the game on Polygon, you get to the point where you have to solve the riddle. MetaMask submits automatically switches to the Sapphire network. You submit your encrypted solution on Sapphire. If it's correct, the Sapphire smart contract will then send a message over to Polygon saying, hey, they got it correct, give them their reward, and then they can keep on playing on the Polygon network. You can even use things like gas relayers, where you pay the token, you pay the gas price on Oasis with the Matic token on Polygon, and therefore you've really abstracted away, the entire process and the privacy layer away from the user. It feels exactly the same as if they're playing the game on Polygon entirely. So that's the way I normally describe the Oasis privacy layer. There's a little visual there, and yeah, we have tons of content on it, and you can always come and ask in our Discord if you have more questions. That's just a bigger version of our diagram. Yeah, I'm gonna skip this in interest of time and to just go over our last product that will be featured in the hackathon, which is Raffle, Runtime Off-Chain Logic. Raffle is a framework which extends to runtimes like Sapphire with support for off-chain components. It allows for more flexible computation, more complex computation that's non-deterministic, which obviously blockchains have to be deterministic, and they allow for access to remote network resources. So they're secured by the same TEs, or trusted execution environments, the little black boxes that I talked about with Sapphire. They're secured by the same consensus layer and the same decentralized validator set. So this means that you can transparently run Raffle. There's no need to install anything new, just the Oasis core nodes and runtimes need to be ran, and that's what you're good to go with Raffle. Basically, it's currently live on Sapphire and can extend to confidential runtimes like our Cypher network as well in the future. Basically, what this means, I don't know if I have another slide on it. Okay, yeah, I'll talk to it here. So you have your on-chain logic, which basically is directly connected to these Raffle networks that are off-chain computation networks. So basically, the on-chain smart contract can call Raffle, and then Raffle has the ability to connect to, for example, like a remote API in a way that it wants to act as an oracle, or it can connect as like a light client. Basically, you can run a light client inside Raffle. So you could have smart contracts on Sapphire, essentially constantly viewing what's happening on the Bitcoin network or the ETH2 network or any network that you want a light client for, without the need for like cross-chain messages, and it's all trustless. And so that's basically where Raffle is at today. In the future, we intend to add what's known as TDX chips and H100 chips from NVIDIA, and that'll actually allow you to do things like run language learning models inside Raffle. So one example I would like to I wanted to just say real quick is like in our last hackathon, we had someone build an AI therapist, which I thought was really cool. So basically, you had an encrypted message on Sapphire, call Raffle, then Raffle would call the LLM, the API, and then submit the message back to the user. Now there are some issues with that. One would be that because there's no way to verify that it's the same user or the same session. Basically, you can't have an account. You'd only be able to have one chat at a time. But in the future, like I said, if we run the LLM inside Raffle, well, then you can actually have like a bespoke conversation that continues over time, as well as it would offer more confidentiality guarantees. So I think probably the use cases today that will be useful for subgraphs will be Opal and Sapphire. But I did want to just bring up the Raffle product for anyone who finds that interesting. I think I went over this, but yeah, decentralized AI, oracles, bridges, light clients, intense solvers, chain abstractions, and defense in depth for decentralized sequencers are all use cases that we see for Raffle. And hopefully some people in the hackathon like to play with it and like to experience what you can do with off-chain logic combined with a confidential blockchain network. That's it for my presentation today. So hopefully that was not too boring for everyone, but let's get into subgraphs and how people can start using subgraphs to deploy their dApps on the Oasis Sapphire network.
Okay, love it. Yeah, I really like that part, to be honest. Really interesting use cases. Okay, cool. Let me just share my screen for a second. Share screen. All right. Can you see my screen?
Yes, I can. Well, yes, now I can.
Oh, now you can. Okay, cool. All right, sweet. By the way, so that's good that you mentioned. We're gonna be indexing data in Sapphire Oasis, so that's gonna be good. Cool. So yeah, first, who I am. I did a little introduction with myself before. My name is Javier Trujillo. I'm a solutions engineer here at Goldsky. I work in the technical services team, and so one of my kind of main duties is to make sure that everyone understands the value propositions of our product and are actually capable of using it. So I'm gonna be going through to our two main products, which is Goldsky Subgraphs and Mirror. And the idea here is that we want this session to be as interactive as possible. So, Will, if you can keep an eye on the chat and let me know if there's any questions from the audience, I'll just stop and go through them. Otherwise, here's my contact details in case you want to reach out. This is my personal email address as well as my Telegram. But maybe for general help, you can email us at support@goldsky.com. Maybe before I start, have we shared the deck in advance? By the way,
with us, no, I don't think so.
Okay, maybe feel free to share if you can, because there is some instructions here in case people want to go over with me through the lab section, through the practical part.
Okay, we'll be working on that on the back.
Okay, cool. Thanks. Yeah. All right. So the agenda for today, I'll just assume that people are not that familiar with indexing in general. So I'm going to cover the basics of what indexing is and why it's important. And then we're going to be going over subgraphs as well, really covering the basics all the way up to Goldsky instant subgraphs, which is basically a way for you to deploy subgraphs with basically no code at all. You just input some config file, and then we provide all the necessary code for you, or we generate that code for you. And then we're going to take a look into what's beyond indexing with subgraphs, and we're going to be looking into Mirror. And so Mirror essentially allows you to create real-time pipelines into your own database. So you can kind of own the data, as we say it. As I said, there will be a section for Q&A in the end, but I'd much rather have questions coming up as we go through the presentation. I think that makes more sense. So feel free to ask any questions in the chat. Okay, cool. So let's start with the basics. Why indexing is important, right? So as we all know, blockchains are a continuously growing list of records, right, of logs. And if you think about the amount of data that there is in these blockchains, it's actually quite huge to consider, especially if you just like zoom in into just one block. You realize that there's a ton of useful info that you may want to be using. So just in one block, for instance, you're going to have information about the block itself, right? Like the height of the block, the amount of gas that was involved in it. Then you will have to multiply that by the number of transactions that there is in each block. Within each transaction, there is also a ton of information in terms of the logs that have been emitted by events on the smart contracts being called, as well as the traces of the contracts that are being, basically calling functions from each other. And there could be more data, maybe even related to MEV and all the stuff that may be relevant to your application. So as you can see here, there's a ton of information on the chain to consider, and not frequently or not historically, the way we have been querying this information has been very, very optimal. Let's say that historically, the way we've been doing like reading this info has been very kind of ad hoc or reactive. At first, we were reading the data by using ETH RPC calls, maybe directly calling the blockchain through public methods in the smart contracts, or some sort of similar way, right? Here I have a little example. I don't know if you can see it, but basically, if you follow this very reactive approach, which we did for this test over here, we wanted to display just like a simple collection of 20 NFTs, right? Which is actually quite simple for today's, general dApps. And so this involved up to 41 network requests, and it even took like around 10 seconds. So you can think about this to be pretty bad user experience, right? Because just waiting 10 seconds to display 20 NFTs doesn't sound like a very scalable approach. And this is because you're basically calling up blockchain each time that you want to gather information, which puts a huge load not only on the client side, because the client has to make network requests all the time, and also in some cases decode the information, but also on the blockchain itself, because the nodes will have to spend some compute on basically serving those requests. So this arguably is just pretty cost inefficient and also pretty bad user experience for the ultimate customer. So this is when indexing pretty much came as the natural solution, right? Indexing, what it allows us to do is it allows us to have a separate off-chain indexer or let's say database, which basically keeps track of the continuously growing records that are created by the blockchain. All these records that we talked about earlier, these indexers are going to be just basically scraping that data and then save that data in a structured database separate from the blockchain, in a way that allows us to do more complex queries, and in a way that allows us to basically optimize the data layer separately from the blockchain itself. So this is a much more resilient and a much more efficient way of querying data from the blockchain itself. Today, indexing, it's basically the de facto standard when it comes to powering front-end applications, not even front-end, but also back-end applications and APIs. Everything you see when you go into Web3, and even if it's gaming, even if it's DeFi, even if it's going to be about, for example, some sort of, for example, trading applications, very, very often, or 99% of the cases, that's going to be powered by some sort of indexing technology in the background. When it comes to indexing technologies today, we can argue that subgraph is basically the most widely accepted and widely used one. Essentially, subgraphs, what allow you to do is just like any other indexer, they scrape data from the blockchain. So when you configure your indexer, your subgraph indexer, you're just gonna point to whatever chains you're interested into index. The subgraphs will start basically indexing the data, and they will store the data in a PostgreSQL database within it. And then it will also expose a GraphQL endpoint for you to be able to query that information. The reality is that this subgraphs technology was developed by The Graph, which is, they made it open source. And in our case, in Goldsky, basically, we have taken this technology, make it full compatible, but at the same time, we've kind of improved it in several ways, right? Be it in query performance, reliability, SLA support, etc. As well as we've added features on top of it, like what we call instant subgraphs, webhooks, tags. We've also added some sort of load balancer as well, just to make the whole developer experience a lot better and a lot faster for you guys to be able to deploy these subgraphs in whatever network you're interested in. So that's pretty much the gist of it, or the theoretical part of it. Now we can get into, let's actually get into deploying some subgraphs from, into Goldsky from the Oasis network blockchain. And so what we're going to be doing here, the goal is going to be to index an ERC20 contract. I took Rossi because I saw that in Sapphire to be the top ERC20 contract. The process here is actually going to be very similar if you're doing ERC20, ERC1155, 721, or any sort of token or any sort of contract you're interested into. So the idea here is that I want to walk you through the basics of doing a standard deployment first, which is basically the way you will be doing deployments using the Graph CLI. And then we're going to be looking into how to deploy these subgraphs also using Goldsky instant subgraphs, which, as I mentioned before, is a very convenient way to deploy subgraphs because basically you don't really have to deal with any code at all we're going to be creating the code for you. Okay, so if you want to follow along here, this is the kind of the prerequisites that you will need. You will need to have the Graph CLI installed for the first method of deploying subgraphs. So this Graph CLI, as we're going to see in a second, is going to create for us scaffolding folders and documents that we just need to edit before creating the deployment. We're going to need, of course, to have Goldsky CLI so that we can take that build of the subgraphs and deploy it onto the right Goldsky project. And then we're also going to need to have, or logging into the correct project. So the CLI is actually deploying onto the right network. Cool. Maybe before I do that, I can quickly show you what this looks like. I have this open over here. So of course I have all these prerequisites opens or installed already. One thing you might want to do is if you go to Goldsky here and you don't have an account yet, you could just go to goldsky.com, go to dashboard. Maybe not here actually. I'm gonna just do it in a private window. So you see. So you go to goldsky.com dashboard. Yeah. And then here, basically, you can create a new account just with an email address. And it's going to give you access to a free trial account, which allows you to deploy for free up to 3 subgraphs and 1 pipeline, which is more than enough for this workshop today. And you don't need to input any sort of credit card into it. So that's actually very convenient. Cool. So as I said before, I already have all of these created, right? So no need for me to do any of that. In fact, if I go to, let's actually open up here. Let me create a new window. Cool. All right. So I'm already logged in. I'm going to go to my workspace. Here you will see something similar. I already deployed a subgraph before, so you can see here. I can actually delete that, so you will see a pretty similar environment when you start off. Let me just do this here. Maybe, let's see. Okay, cool. All right, so when you start, you're gonna see pretty much this pretty similar approach. So we're gonna start off fresh with a new project from Goldsky. Okay, so the first thing I want to do is first, as I said before, I want to show you how to deploy subgraphs using the Graph CLI. And by the way, let me just close here because we have pretty noisy birds in the house.
All right, no worries at all. Thank you.
Yeah. Cool. All right. So first thing I wanted to walk you is just for you to become familiar with how to deploy subgraphs using the Graph CLI. And the reason for this is there's a lot of, I would say it's really useful when you are able to read subgraphs, which are publicly available out there, and you just copy them, edit them to deploy your own logic, which is actually what a lot of people do. Like, for example, if you are doing some sort of Uniswap-like contract, that's actually what a lot of people do, really. They just go to GitHub, read the code, modify it a little bit, and deploy it onto the network. So when we do the CLI from the graph, you will see now that it will create a scaffolding, some sort of structure of documents for us that we will be working on. We'll have to deploy onto Goldsky. And out of these files, there are 3 main files that I want to call out specifically. There is the subgraph YAML file. Within this file here, basically you will define what contract and what events or information you're interested in. So we need to specify the network, contract address, block, API, etc. Then the schema GraphQL here, we're going to be defining basically the kind of the data layer, the schema of the data, or you can think about the data model maybe. In it, you will have to define what's called entities. And so entities are essentially the objects that you will ultimately be able to query via the GraphQL endpoint, which I explained earlier, that the subgraph will expose. And then the mapping is basically the logic, right? Mapping is where you say, okay, based on these events that I want to track from this contract, for example, now that we're going to be doing ERC20, right? We will probably be indexing the transfer event. So within these files, when they say once we see or we track a specific transfer event, what's the logic that we need to follow to ultimately save whatever entity we are interested in querying at the same time. So we're going to be looking into that in more detail now when we build the subgraph. Cool. So the way to do this is with the command graph init, right? Graph init is going to start off an interactive process by which we can essentially create these scaffolding of documents. And so one thing I want to do here first is I will probably, you will probably want to have the ABI handy because as part of the process, the tool or the graph CLI is going to ask you for the ABI of the contract that you want to index. And so what I want to be doing now first is I'm going to be tracking, or we're going to be deploying a subgraph on the Ethereum network. And then we're going to modify that contract or that subgraph to deploy it onto the Sapphire network. And the reason why we do this process first is because the graph doesn't index Sapphire network yet. So we have to just do a normal deployment with Ethereum, and then we'll edit it and deploy onto the right network later. So to do that first, I want to be going into Etherscan, which is basically, this is a very common process, by the way. You can go to top tokens. What I'm going to be doing here, because we just want an ERC20, right? Any token will just like be okay because they all follow the same contract basically. So I go to USDT, for example, go to contract, and then down here we have the contract ABI. So first I'm going to copy the ABI, and then I'm just going to do let's just do the ABI JSON. It's going to copy over here. All right, cool. So now we have the ABI JSON. Now we can start with graph init command. So now graph init is going to ask us for some info. As I said before, because the graph doesn't index the Sapphire network, we are just going to choose Ethereum for now and do a normal Ethereum deployment. You can just choose whatever option here because this is asking you essentially where you're going to be deploying. We're going to be deploying to Goldsky, so this doesn't really matter. You can choose any option. The subgraph slug, I'm just going to say that this is going to be USDT. The directory is good. This directory works for me. Then the network is going to be mainnet for now. Contract address, we're going to copy the contract address of the USDT. And again, we're going to be changing this later. It's going to try to fetch the ABI from Etherscan. This doesn't really work. At least it doesn't work for me, never. So that's why I copied the ABI and put it on a local file. So I'll just say don't retry. And then it's going to try to fetch the start block, which doesn't really usually work as well. So what I like to do here for this example, I'm just going to go to the transfers. I'm just going to take, let's say, for example, this block over here. Let's just say no. Okay, 1 second. ABI path is going to be .abi JSON. This is where my ABI is. And then for the start block, let's just take something like maybe a few blocks behind. Okay, cool. Contract name, which is going to call USDT. Index contract identities, and then yes. Cool. So now this, with this information, the graph CLI is going to create the scaffolding that we need to deploy the subgraph. And again, let's actually look into what's going to be created. I'm just going to deploy this for the purpose of demonstration, but I think the interesting thing is going to be how we modify this subgraph to point to the one in the Oasis network, which is called Rosie. We're going to see how we can do that now in a second. Okay, cool. All right. Let me clear this. And now let's look into, we have this USDT created. So just going to open up with my code editor. Cool. Yes. And then hide this. Oops. All right. So you can see here, let me make this bigger. Cool. So you can see here that we have a bunch of files created for us. As I mentioned before, the most important ones are going to be subgraph YAML file. In this file, we can see here the information that I mentioned before. Basically, the subgraph or the contract that we want to index with, we have here the network, which is for now mainnet, the address of the token, the start block, And then we see that by default, what the Graph CLI is going to do is going to create these mappings for us. It's going to create these entities, right, which we're going to be able to query this information. And by default, it's just going to take the API of the contract, and it's going to create as many entities and mappings as events it finds within the API. So these are all events that it finds within the ERC20 contract. And for each of these events, it creates an entity, as well as it creates its own handle, which is actually pretty simple code. If we look into the GraphQL, which is basically, as I said before, this is the data layer, right? This is the objects that we're going to be querying. Formally, they are called entities. You can see here that they basically, let's look into transfer, for example. If we look into transfers, we see they have the ID from toValue and then some metadata in it, right? So this is basically the params that you will be seeing in the within the event itself. If we now go to source and the UCT, this is the mapping. And let's actually look into transfers again. We see here, for example, we have as a param to the function the event itself. And all we do is basically take the params and save them as attributes of the entities. So this is a very, very simple and default subgraph construction, basically. So that'll be it. Now, what we need to do is we're going to take this and deploy it onto Goldsky. And so to do that, let me open up a new terminal here. To do that, as I said before, you will want to have your your project on Goldsky already created. I already have mine over here, right? Another thing you will want to do is basically have the CLI with the Goldsky CLI pointing to this project. So to do that, you can go to settings, hit new API key, create a new API key. That's going to give you a string. And so what you need to do is do Goldsky login, and then you can input here the API key, right? So that's a way for you to basically to point to your project within Goldsky. I already did this, so no need for me to do it. Now, what we need to do here is when we have this code, we need to run code gen and then build, right? Sorry, actually, let me see. This is graph build. Graph build. So what graph build is going to do, it's going to take all this code from the generated folder, which is already being created for us, and it's going to create the corresponding WASM files within this build directory. You see it right there, right? So now here, all we need to do now is we can just deploy. And so to do that, we do Goldsky subgraph deploy. We need to choose a name. So the way you choose a name for the subgraph is you put a name. So I just got to call UZT mainnet, and then dash, and then a version. So I can say 1, for example. So we do this. And now basically the Goldsky CLI is going to look for the build folder, and it's going to deploy the subgraph onto my project. So this is going to give us now the resulting GraphQL endpoint that I mentioned before. If I click on open here, we're going to be redirected to the GraphQL endpoint here. If I go back into my subgraphs, you'll see now that we are indexing the subgraph in mainnet, right? And we can see the indexing status of it. Let me actually look. So if you click on it, on the number, you're going to get into the details of the subgraph itself. So going back to the GraphQL endpoint, one thing I like to do here is if you look into the left side menu, you have this little folder over here, which is Explorer. It's a very convenient way for you to be able to create queries against the subgraph. Each subgraph is going to have its own entities that you can query. Using this Explorer over here, you're going to see, what entities are available, and it will also help you create very easily, basically query objects for you to ask for that information. So for example, if I want to get information about the transfers, I can click here. I can say I want the first 10 transfers. That's good, and I want to get the from ID and to and value, right? I click play. And then I get all this information here. So this info over here is basically the same one that you will see on Explorer, essentially, right? Okay, cool. So that's the basics of deploying a subgraph onto Goldsky. But let's actually make this more convenient for us, right? Because we are here to deploy subgraphs onto the Oasis network. So in specific, as I said before, we're going to be looking into indexing Rosie, all right? So let me click on that one. okay, which is over here. Maybe I think I lost it. Okay, well, that's convenient. So this is the subgraph that we want to be tracking essentially, right? And so the process will be very similar. We just need to change a few things, right? As I said before, let's go back into the subgraph here. And let's just change the YAML file. So the YAML file now is actually pointing, the subgraph is pointing to mainnet. We want to change this, right? And the way to do this is you want to add the corresponding network flag, which in this case is going to be Sapphire. The way I will look into this is if you go to the docs here in Goldsky and you go to chains, then you can see here supported networks. You can see here all the networks we support, and you can index. If we just look for Oasis here, you can see that we support these 4 networks for Oasis. And specifically, we want to be looking into Sapphire, which is basically where that ROSI contract is deployed. So this is the corresponding network flag that we need to input over here in the network. So that would be it. The next thing we need is going to be the contract address within the network, which is up here. And then we will probably just, for the API, we can still use USDT, right? Because it's an ERC20 contract. It's going to have the exact same contract, API. Star block is going to be different, right? So let's actually look into the transfers for this contract. We see a bunch of them, so maybe I can just take this one here. Let's actually look into maybe an older one. Maybe this is going to be more interesting. Yeah. So I'll take this, something like this, right? We're going to take some blocks in the past. In reality, it depends, right? You may want to have a start block when the contract was deployed. It's really up to what information you want to track. And then the rest, we can keep it as it is. Because at the end of the day, it will be the same exact mappings and same exact information. So that's pretty much it. Now that we have this info, go back to the terminal. What you need to run here is graph codegen. It's an extra command to the one that we ran before. This is going to generate new files. And then again, graph, let me clear this. Graph build. So we rebuild those WASM files. We're good to go now. Okay, cool. And now we can deploy again. So do we say Goldsky, subgraph deploy. Let's just call this ROSI. Let's say ROSI, maybe, yeah, Sapphire 1, for example, and deploy it. Okay, cool. So same exact process. Now we're deploying pretty much this kind of the same code as you saw. We just added a few little changes to it, but now we're pointing to a completely different network, a completely different contract, right? So again, we're given this endpoint, which is going to be pointing to, you can see here from the URL, this is pointing to ROSI Sapphire. The other one was pointing to just the mainnet. If we go back here to subgraphs, we can see that we have a new one being deployed, and now we can query the information here as well. So this is going to translate into, of course, this is going to now be pointing into that ROSI network, ROSI contract in the Sapphire network. So that's pretty much it in terms of how you can deploy subgraphs onto using the standard process. Let's say, right? You take the contract or take the code created for the graph, modify it a little bit, point to the right networks, and then you can deploy onto Goldsky with a simple command. That's actually the bare minimum to start with. Let me go back into the presentation again, which was over here, I think. Let's see here. Okay, cool. Right, so this has been the first way to deploy over there. Another thing you may want to do is, we saw how to deploy contracts, using the basic functionality, right, from the Graph CLI. I took another example and posted over here, so you should have access to it if you have, if you have this deck. I created this other contract over here, which is going to be under this repo and the subgraph. Basically here, if we look into this other subgraph that I deployed, It's a little bit more complex, if you may, but it doesn't really have to be that complex. Basically, what I'm doing is here we have the same, right? We are pointing to the right network. We're still pointing to Rossi contract. You can notice here that I'm saving different entities, right? So this is the token account and token balance. And I'm just tracking the transfer event, unlike the previous one, which was tracking all the events that the ABI contained. And here what we're doing is basically we are modifying a little bit the logic within the mappings so that we can do basically aggregations. And the whole thing here is that instead of just like creating entities that resemble or mimic the information in events, we are adding some extra logic to it to keep track of account balances. So we can see, in this case, how much a specific EOA has of the Rosy token contract. So this is just a way for you to see how you can take this information, modify it a little bit, and make it so that the actual information that you're going to be querying for the subgraph is completely different and completely customized. And this is really what people do when they create their own subgraphs. They really get creative in this area and save the information that's important to their DApp business logic. Okay, so we can do here, what I can do is I can go here, I can deploy the subgraph. So if we go back here, I'm just gonna copy code. So we do git clone, clone it. Cool. If I seed into it, and now seed into subgraph. Cool. Let me just clear this. What I can do here is basically I can deploy the subgraph onto Goldsky again. So how we do this, just like before, Goldsky subgraph deploy. Maybe I'm gonna call these something like Rosy balance, maybe. So what's gonna be doing is I already took the time to create the deployment files for you. So this is the build files for you. So all you need to do is just basically run the deploy command, and you'll be able to deploy this subgraph onto your project. So now this is being deployed. And as I mentioned before, now, because the entities that we are saving are very different to the ones from the other subgraphs, I can notice that here. If I go back to this handy Explorer, and I go to, you can see here that it has different accounts, different entities. So now here, for example, I can say, give me the first 10 accounts with the corresponding balances, with their amounts for the token ID, which is basically going to be the same, right? So I can create more complex queries here because now the entities that have been created in the subgraphs, they have relationships between them. So if I hit click, I can see the balances for different EOAs, essentially, how much Rosy each one has. This is just an example of what you can get to do if you modify that mapping logic, basically. Cool. So that's pretty much it. This is basically how you can create subgraphs or modify the code of the subgraphs. One thing I wanted to also demonstrate here is this thing, which is pretty cool, which is called instant subgraphs, right? And so maybe I'm going to open up this one in my editor instead of from GitHub, which is basically in the other folder of this repo. Let's see. It's called instant. Okay. Let me code now here. Okay, so in some cases, you may not want to deal with code at all, right? We saw that the Graph CLI is going to create that scaffolding of documents for us, which we need to modify. And maybe in some cases, you just don't want to deal with all of that, right? So we created the instant subgraphs to kind of deal with that. Essentially, what we do is with instant subgraphs, all we need to have is a config JSON file and the ABI of the file that we are interested in tracking. And so just with the bare minimum configuration information, we can basically deploy a subgraph, or we will have Goldsky create the files for us and deploy onto the right network. So here, all we need to define is basically what's the name of the subgraph that we want to deploy. Where's the ABI? So basically you point to your local file, which is basically right here. And then within this instances array, basically you define the contracts that we want to track. So basically, again, the address of Rosy, a start block, and a network. This is all we need, really. As you can see here, this kind of resembles the information that we were inputting before in the YAML file, we just input that here in the config.json file, and that's pretty much it. Now I can deploy, I can have basically Goldsky deploy, build the subgraph for me and deploy onto the network by doing Goldsky subgraph deploy again. I'll call this subgraph something like Rosie instant. And then we pass in the flag from ABI, and then we pass in the actual config.json file. So now here, as you can see from the output, we're going to be generating the subgraph for you, basically all the scaffolding that you saw before that we were creating manually, and then this is just deploy. So pretty simple way of deploying subgraph using basically the Goldsky command. No need to know how to run the code. So now here we have the transfers again, and we can query this info over here. Cool. So that's pretty much it. That's just a way, in case you don't want to deal with all the scaffolding and all the code from the Graph CLI, you can just basically go ahead and use instant subgraphs. Of course, like if you're wondering what type of information is actually being indexed, by default, the instant subgraph is going to take all the events in the ABI and create entities that resemble those events. But you can get more complex, and you can do what's called enrichments, which are better, explaining more details here. I show you here. If you go to our docs, and then you go to, let's actually see here, instant subgraph configuration, you can see here that you can do enrichments. So you can extend the logic just with configuration, not with no code. You can extend the logic a little bit and modify the way that the actual instances or entities are stored. This also allows for very complex or very interesting deployments. For example, within the same file, you can deploy multiple networks. So you can deploy some sort of multi-chain application as well, just with one configuration file. So in this example here, we were pointing to mainnet, Avalanche, Nitmos, and a few others, just using one config file. Once you run this is gonna, the result of it will be different subgraphs pointing to different networks, essentially. So you could be doing this for example, you could be creating an instant subgraph configuration that deploys as many contracts as you're interested in different networks within the Oasis blockchain. All right, so that's pretty much it in terms of subgraphs. One thing I want to call out just to kind of finish off this section here. Let me see if I can make this. I cannot make it bigger. I guess it's fine. Cool. There's a few more things which we're not going to have time to cover today, which are very interesting when it comes to subgraphs with Goldsky. You can have, for example, webhooks that allow you to notify external systems of yours via HTTP endpoint whenever, for example, an entity is saved. You can also add versioning to these subgraphs. You can also create private endpoints. So in case you don't want that GraphQL endpoint to be public, you can also make it so that only people with a specific header can query that information. There is a lot more to that you can uncover when it comes to subgraphs. So I would definitely encourage you guys to take a look into our docs for that. Cool. So now the last section on indexing, which I wanted to cover in this presentation, is what's next beyond subgraphs. As you can see here, or we've seen in this example so far, subgraphs are actually very, very powerful, and they power a ton of real applications these days. But the reality is that subgraph is kind of the tip of the iceberg. As your application grows and you need to kind of meet more complex data business needs and requirements, you're going to see that subgraphs can actually kind of fall short to meet those requirements. And so the reason for it is really scalability, right? As you saw, all the information that we can query from the subgraphs is limited by one GraphQL endpoint. And so if you have to satisfy other use cases, like, for example, cases where you need to combine off-chain with on-chain data, maybe where you need to do some kind of really, really performant, fuzzy search, maybe you need to do analytics, etc. That's just not going to scale very well without a GraphQL endpoint. It's just the way it works. And so the reality is that as your application grows, it's just a matter of time that you're going to be starting to kind of front and face those challenges. And subgraphs is just not gonna make the cut, basically. And so to deal with this limitation, we created Mirror. So basically, Mirror, we like to think about it as the next evolution in terms of data retrieval within Web3, because what we do here is that we allow you to create real-time pipelines that basically take that on-chain information, that on-chain data, and allow you to send it to whatever technology of your choice based on your specific data use case. So if you have a need for example, a real-time analytics, you can take that data and stream it into something like ClickHouse. If you want to build an API on top of your on-chain data, you can basically stream that information to Postgres or MySQL and then put your own API in front of it. So essentially, we allow you to take the on-chain data and then collocate it with your own warehouse so that you have a much more efficient way of working with that data. And it's not only about the actual on-chain data. We also allow you to do more things with it, right? You can combine what we call the sources, which is basically the left-hand side of here. You can have off-chain data stores, for example, your own MySQL database. You can combine that with on-chain information, for example, something that comes from a subgraph. In between, in the middle of the process, you can run transformations. So you can maybe, for example, take that code, do joins on the code, or maybe you can also, for example, filter on a specific addresses. There's a lot of things you can do and that you can express with SQL commands that will be executed as part of the pipeline. So it's all about, there's a ton of flexibility in the source of the data, in the transformation of the data, as well as in the sinks, because you will be able to be deploying that data and streaming it in real time into whatever technology of choice for your use case you need to satisfy, essentially. And so that's going to be Mirror pipelines. I want to quickly show you how this is done here within the platform. So the way you will be deploying Mirror pipelines essentially is rather simple. You go here back to the app. You can go to pipelines, and then you can create a new pipeline by clicking on this button here. You will have two options, right? You can choose the source of your pipeline to be a subgraph that you have deployed before, or what we call direct indexing. These direct indexing are basically raw data sets for the chain that you're looking for, like logs, blocks, or transaction data that you can also use as the source of your pipeline. But basically, for this example, maybe what we can do, we can choose subgraph as the source, and then we can take one of these subgraphs that we were deploying earlier in the workshop. So, for example, I can take this rosy sapphire, for instance. We can choose it to be the source of our pipeline, and this is going to take us through basically a wizard that will allow us to deploy the pipeline. So we can click create pipeline here. Now we need to input some basic info about the actual pipeline. So a name, and we can choose the default name of it. The resource size is basically how much compute we want to add into these pipelines. With a small one, we are pretty much good to go for this small example. But in cases where you want to deal with a lot of information, you may want to increase the resource size. Then we can select what entities from that subgraphs we are interested in streaming. So I can say, for example, I just want to get transfer data onto my database. So you can just choose transfer. And as you can see here, as I modify this information, this YAML file on the right side is going to get filled in. The YAML file is basically how we formally define these pipelines, but you don't really have to worry about that because we're just going to do it through this interactive process via forms on the left side. And now here we can choose a sink. So basically, sinks is the destination of the data. You can choose among different integrations we have created. In order for us to be able to write to that sink in a secure way, we need to create what's called a secret beforehand. So a secret encapsulates the credentials to talk into your database. In my case, you can see here, I have a bunch of secrets towards Postgres databases and ClickHouse. In this case, I typically use this database for demo purposes. It's called, basically is a NeonDB. For those of you who are not familiar with Neon, Neon is basically...
Javier, I just want to let you know we're a little bit over time already, so if we can wrap it up in the next couple minutes.
Oh yeah, cool. I'm just gonna wrap it up here. You can just like deploy here, deploy the pipeline, and basically this is gonna deploy a pipeline towards my database, which in this case is gonna be NeonDB database, which is over here. So I did this example before just to show you guys. I did the exact same steps and deployed this information onto Neon just before the workshop, just to show you the results of the streaming pipeline. So that's pretty much it. Cool. There will be a feedback link here, which I would love you guys if you can fill it in case there's something we need to improve or any other information you want more data about. I guess there's no time for Q&A. So yeah, thank you so much for the time.
Yeah, absolutely. I'll just let everyone know the deck I posted underneath the Twitter, I guess the Twitter space, but also it'll be added to the YouTube video and all that. So if anyone wants to find the deck so they can go through it themselves, or if they want to, give the feedback, I know the Goldsky team would really appreciate that. Thank you so much, Javier. I think this is a great tutorial for anyone who wants to deploy a subgraph on Oasis. Before we go, I just have one question that we'd like to ask all of our guests, and that's like, what are some of the use cases that you think are most interesting, either with subgraphs, useful for subgraphs, or like with confidentiality in Web3?
Yeah, sure. I think with subgraphs, really, we can see a bunch of them. With subgraphs today, you're pretty much used to seeing these everywhere when it comes to, as I said before, it can be used for, we have a lot of customers which do finance applications. So that could be an example of it. Specifically to privacy, I'm pretty curious to see, like, because you were mentioning this before in your presentation. I can imagine that there will be a lot of data that these subgraphs can track, but that ultimately the application will be having the logic to the code, because you can still keep track of those events, but ultimately the information is private, right? So I guess the DApp will be the ultimate source of truth for the data that is being tracked by subgraphs. So
the Illuminex team, when they launched their V1, they use the events to aggregate what the amount of liquidity in the liquidity pool was, while keeping the the user themselves and what pool they're putting into and what trades are being made confidential, which I thought was a really cool use of Goldsky subgraphs plus the Oasis confidentiality network.
Right. Love it. Yeah. And I think, if you're going to go a step further, because I get this question asked a lot, like, when would you use mirror over subgraphs, right? Like, if you take that example, if you take that at scale, subgraphs are not going to scale well with that example. So at some point, you will want to have that information being mirrored into your database, because that's going to scale a lot better. If you have a lot of requests, a lot of events, it's a lot better if you just have mirror on top of that. So you can just basically have control over the latency times as well as the query times as well.
Yeah, I love it. And the other thing that I wanted to mention is I would like to implore people, if they're using Opal, like you said, you basically can deploy subgraphs on, any network. And I think that'll help with the analytics or, just the user interface between using these cross-chain communication platforms that the Oasis privacy layer might leverage. So with that, I guess I'm going to give my last plug and goodbye, and you can plug anything that's going on your side, Javier.
Cool.
But yeah, so Oasis is participating in the AI Summit in Amsterdam this week. So if anyone's there, please check us out. We'll also be at DevCon in November. Besides that, if you have any questions for us regarding the hackathon or anything else on the network, just join our Discord, come on, follow us on Twitter, anything like that. We're happy to answer your questions. And I implore anyone who's a developer who wants to play with some cool technology that's sort of novel to Web3, participate in the hackathon. There's $130,000 in prizes, and we have some pretty cool products that have already started getting built. Anything on your side, Javier?
No, yeah, thanks so much, guys. I would say that, you have my details on the deck. So if there's any questions, feel free to reach out to us. We really want, to help you be succeeding in this hackathon. So feel free to reach out to us, and we'll definitely help you with your use case. Thank you.
Awesome. Thanks so much, Javier, and I hope you have a great rest of your day.
Talk soon. Too. Thank you.
Bye.